Good morning. Thank you for taking the time to join us for today's webinar and demonstration entitled Protect the Unprotected with the Aruba CX10000 series switch. Leading today's discussion and demo is Jason Gmitter, Senior Director of Solution Engineering at AMD Pensando. We are also joined today by Tori Long, Systems Engineer at AMD Pensando, and Mike DeVita, Vandis' Principal Mobility Architect, who will moderate questions with Jason. In October 2021, Aruba introduced the next evolution of switching architecture, the industry's first distributed services switch with AMD Pensando. The Aruba CX10000 series switch delivers advanced scalable network and security services for enterprise data centers. For those of you who are new to Vandis and Aruba have had a close working relationship for over 16 years. We are a platinum level partner and have one of the largest Aruba certified engineering teams in the Northeast. Our team also sits on the Aruba Advisory Council, and we are excited to share this solution with you today. We are recording today's session and ask that your microphones remain muted. Please feel free to submit your questions at any time via the chat, and we will address them during the demo. Lastly, a quick reminder to visit our website, vandis.com/events, for a list of other upcoming events that you might be interested in. And now I'll turn it over to Jason and Mike.
Good morning, everyone. Let's get started. So when we think about distributed services and this switching architecture evolution, it's always a good thing to take a look at the past and understand what were the problems, or what are the problems that we set out when we built this platform we wanted to solve, and how did we do that? So if we look over the last 10 plus years, we saw an evolution in switching architectures. Back in the day, we would build back-to-back VPC or back-to-back MLAG data center fabrics that still had spanning tree underneath the covers, but we had basically, with things like MCLAG or VSX, you can make two switches logically look like one. So you would almost build these hub and spoke architectures. But then it evolved into, we needed to build larger fabrics or get away from relying on spanning tree. So we started to see multi-protocol EVPN VXLAN based fabrics get built out, or you saw more proprietary solutions like ACI, for an example, to build out these fabrics. Okay. But one of the challenges with them is they never addressed how to provide stateful security within the fabric. What you would get is either a stateless ACL, a very rigid and flat security policy model. So even to this day, when I speak with customers that have deployed those technologies, what we ended up seeing is they ended up bolting on firewall appliances and not putting the default gateway in the fabric. They end up putting the default gateway on the firewall so they can insert that firewall because service chaining was too difficult. And we all know the challenges with that. Or then we started to see customers install software sensors or agents on their workloads to provide different types of security. And it just kept adding to the complexity and cost of these data center fabrics that they needed to secure their workloads. And this is where, instead of essentially the proper word is this the evolution to, we don't want to change the way you're building data center fabrics, because I think the way they're being built today are great, but now we finally are able to deliver on distributing services embedded within the fabric, stateful services, instead of bolting things on. So what we've done is we haven't built this proprietary approach. We built an open framework on saying, yes, build your data center fabrics just how you've been over the last couple of years, but now take that security intent that many vendors talk about, but now take that security intent and distribute it within your fabric so it's now stateful across every entry or exit point of your data center fabric. So that's what we're going to talk about today, is how to essentially statefully enable services across your data center fabric. So the way we're doing that is we've partnered with Aruba, leveraging the AMD Pensando DPU. So what have we done to date with this Pensando DPU? So we've delivered software and services with VMware, which will be outside the scope of this conversation. We'll talk, much of our conversation today will be about how we've taken this DPU and embedded it inside of your network fabrics, your data center fabrics, and in some instances, even campus fabrics. And then lastly, it's embedded in hyperscalers today. Microsoft Azure, Oracle Cloud, IBM Cloud, and many others are adopting this technology to help them scale their services on behalf of the customers that run across their floor tiles in their data centers. So we break this out. This DPU, you'll see it embedded in Project Monterey with Dell and HPE. We'll talk today around the Aruba CX10000 that leverages this DPU to provide these distributed services. And then, as I mentioned just a moment ago, Azure, OCI, and IBM Cloud. So this technology scales extremely high, and we're bringing it to the enterprise. So let's get started in regards to what we built for the enterprise. So what you have here on the lower right of the slide is the Aruba CX10000. It's a 1RU top-of-rack leaf switch. The internal components of it, it's a Broadcom Trident 3 chipset. So anything related to layer 2 switching, layer 3 routing, anything related to control plane around routing and switching or EVPN VXLAN fabric, that is all handled by Broadcom in the Aruba CX operating system. What you'll see is there's two Pensando DPUs, distributed processing units, that are connected via dual 400 gig bidirectional connections. This is where the stateful services are able to be provided. So I hope you're thinking, okay, what are the services? And then how do you get a packet that comes in one of these front panel ports up to these DPUs? And one of the things I love that we did is we made it simple. Service chaining or injecting these services on behalf of the flows has traditionally been so complex, and we've made it extremely simple to do. So first up, what are the services that we can provide at the top of rack leaf switch, distributed services leaf switch? The first is we can provide a stateful firewall. That includes micro-segmentation, macro-segmentation, and zone-based segmentation, and it is stateful. The next is we provide very rich telemetry. You get a firewall log for every flow. You get the option of also getting per packet IP fix as well, and being able to send that off to different collectors with a flexible parser engine. You also have the ability to turn on hardware-based NAT, where in the event you need to share services between Verfs, or you are going through an acquisition or a divestiture and you have overlapping IP addresses, or you're connecting out to a public cloud and you have IPv4 exhaustion and you need to start NATing addresses. Instead of paying for an expensive firewall to do that, it's now at the cost of a top-of-rack leaf switch. In that form factor, I can provide NAT services as well. And I can also provide up to 400 gigabit per second of IPsec encryption for site-to-site VPN tunnels as well. Now, let me circle back. How do I get a packet that enters in one of these switch ports up to these Pensando chips? It's not PBR, it's not NAT translation, it's not putting the gateway up on the DPU. It's much simpler. It's literally just defining this Verf and these VLANs I'm interested in. That's it. And then as soon as a packet enters and we look at the IP header of that packet and we identify, do you match on this Verf and or VLAN, the first order of operation is redirected up to the Pensando AMD chip. Provide one of these or all four of these services. And if it's a permitted flow, we send it back down to Broadcom and have it make a forwarding decision on what egress port to send out. That's it. That's how simple it is to inject these services on behalf of the packets ingressing and egressing out of this switch. All in the form factor of a 1RU top-of-rack leaf switch. So let's go through a couple of use cases. As I mentioned on the opening slide, there have been a number of different approaches that we've seen customers that have tried to take their data center fabrics and bolt on security. whether it's via installing NSX as an example, or Cisco Tetration, Illumio, or Guardicore software agents. One of the challenges with that is if I can get the agent installed, great. But I think we all know you're never going to get 100% coverage on getting this sensor or agent installed across all your workloads. Let alone, what about the control plane in your data center that you can't get an agent installed on? And then, as I also mentioned, we see a lot of customers deploy firewall appliances at the end of the row. And instead of keeping the gateway in the fabric, especially in a VXLAN fabric and as a distributed anycast gateway, they end up keeping the fabric just L2 and they put the gateway on the firewall, which becomes a tremendous bottleneck as it relates to connections per second. The old school way of doing it, but it was a necessity because there were no other options. Because a stateless ACL that was flat and rigid and not enough TCAM was no longer an option. So we had to look at these options, but now there's a better way of doing it. So by taking that stateful firewall function, we're able to distribute it to the top of the rack leaf switch, where we're able to now, whether it's migrating those firewall policies, if it was macro or zone-based segmentation, we're able to migrate those policies and now have them statefully enforced, taking that intent and distributing it within the fabric where it can be statefully enforced, provide a firewall log, where I have enough capacity to hold up to 1 million rules per switch. That's unheard of, right? You typically can install a couple of hundred, maybe a few thousand if you're lucky, depending on how you write them. In a traditional commodity-based switch, we can hold up to 1 million rules per top of rack leaf switch here. So you can take those large policies off of your third-party firewalls and now distribute them within the fabric. The other thing we can do is we can take policy from Guardicore, from Tetration or Illumio, and where you're not able to install a sensor or an agent, we can now take that policy and enforce it at the top of the rack. And that includes micro-segmentation as well. So in a VMware environment, we're able to dynamically provision the private VLANs that will plumb the traffic up from VMware, and it's supported by VMware. We can take that east-west lateral traffic that would happen inside of an ESX server, come up to the 10K, statefully inspect it, generate a firewall log, send that off to your SIM, and if permitted, allow it back down to its destination. So what you're basically getting at the top of the rack is 2 1RU switches deployed in a VSX pair. That gives me 1.6 terabit per second of stateful firewalling at the top of every rack within your data center. And that scales out every rack you deploy, 1.6, 1.6, on and on, every time you deploy a pair of CX10Ks. So I have stateful inspection, firewall logging, the ability to generate telemetry, whether it's firewall logs and or IPsec on a per packet basis, and streaming that off to your existing tool sets. And I have a very flexible policy model where I can take existing policy and migrate it over into this environment. And we also have the ability to discover policy as well. One other use case that I wanted to cover, and this is something that we are just wrapping up beta and we'll be shipping FCS code on this, is in a border gateway function, taking the CX10Ks and deploying them as a border leaf or border gateway. We, as I mentioned, the ability to support NAT and IPsec. So we have a large hosting provider. In fact, there's 2 of them that are going to be the first customers out of the gate deploying this, where they're bringing customers or branch offices or other locations into their data center. And what they were doing is they were deploying those site-to-site VPN tunnels using virtual firewall appliances. And it was a huge cost and very complex to manage. So they were providing site-to-site VPNs to third-party firewalls. And because it was a shared environment, they had to deal with overlapping IP addressing. What we've taken them from is dedicated appliances per customer, and now we have deployed 2 RUs of border leafs where we're able to terminate all of these third-party VPNs while also providing NAT and stateful firewall, and then dropping each customer often to their own Verf inside their data center to access their applications. And I'm sure you can imagine the cost savings they've taken out by moving from this dedicated architecture to a shared architecture and only consuming 2 RU out of a rack to get up to 400 gigabit per second of IPsec, firewall capacity, and NAT translation. So the rack space is drastically reduced, the licensing is drastically reduced, and the performance has jumped through the roof. So to summarize, in 1 RU, you're getting a stateful firewall that allows me to implement micro segmentation, macro segmentation, as well as the ability to migrate zone-based segmentation as well. Then you couple on the ability to take firewall logs, IPfix, turn on NAT and IPsec when it ships next month. There's a tremendous amount of cost reduction you can drive with this particular architecture.
Okay, that sounds great. So I know that Aruba already has a comprehensive management platform for their data center portfolio.
Yeah.
Things like Fabric Composer and NetEdit. So how does this integrate with that, or is it a completely separate tool that you have to worry about?
Yeah, it's a good question, Mike, and that comes up pretty much every call we have. So we've taken into consideration some customers have merged network and security teams, which is fantastic. Other customers are still very segmented. So we've taken the approach of being able to address both. So what we have is the Policy Services Manager, PSM, which I will take you through today through the demonstration for the rest of the call. That PSM is what allows us to centrally control all of the policy that we talked about for firewall, NAT, IPsec, IPfix, and so forth, and we distribute that policy and intent across the leaf of your data center fabric. That's perfect for the security team that wants their own tool to manage. For those customers that are merging into one team, there's Aruba Fabric Composer, which allows you to do all of your network configuration as well as leverage the APIs that we expose via PSM. So I can build all of my security policy, my NAT, IPsec policy, all through AFC if I wanted to as well. But we allow, again, just recapping, if you guys have merged your teams, great, use AFC to do everything. That will the security policy will go through PSM, and then all of the network configuration will go directly to your CX switches in your data center. Now, what I do want to highlight is today we're going to do everything through PSM, and later on at the end of the call, Joanne's going to talk about we'll focus specifically on AFC. We won't cover AFC today, though. But luckily, we, like I said, we're going to have 2 more sessions later in May and June on this particular topic. So what I'm going to do for the remaining time for today is I'm going to take you through PSM, and Mike and I are just kind of going to go back on dialogue on how you build things with this particular tool. So, Mike, let's get started. Where would you like to start?
So, I mean, I think one of the most interesting things is the East-West firewall capabilities of the platform. So, I mean, how do you create a rule? What does a rule look like? How do you build them? Yeah,
I think that's a perfect place to start. So, if you look over here on the tabs, right? First, you can see all of our switches in our particular labs. We have some border leafs, and then we have traditional server leafs. And what's nice about this is I can launch this directly into direct access into the switch if I wanted to do any network configuration. But this is all of what we focus on here is security policy. So first up, the security policy tab. I want to build a firewall rule set. So the first way we can do that is we can come in and we can give it a name. Let's just call it Vandis for today. Let's call it rule 1. We have a permit or deny action. We can give it a description, and we can also leave it enabled, or we can disable it. And maybe we just want to build the rules now, but we don't want to enable them just yet. We want to enable them when we have another time. We have a maintenance window where we want to turn these rules on, but it allows me to pre-configure them, which is great. And then what you have here is just like you would in any traditional firewall environment. I can come in and I can build my my source prefix, just as an example, talking to a destination prefix, and I can define my port and protocol with that. And that's rule 1. And I can essentially, let's do any just to keep it simple. So that's one way of creating a rule that's within a policy, right? And this would get distributed to all of your leaf switches, basically. And again, this is a pretty generic rule, but basically saying these 2 subnets can talk to anything within my data center, as an example. What do you think, Mike? Any follow-up questions to this?
Yeah, so I mean, you said you could create like 1 million rules in this system. So obviously doing rules based on that 5 tuples could be cumbersome. Are there ways to group, systems together, rules together using, groups or tags or something like that?
Yeah, it's a good point. It's kind of like with NSX, right? You would never do this with NSX using your 5 tuples. You'd leverage tags and labels to do that. And that's something we've totally taken that into consideration because, as you know, right, in order to build policy, you have to understand what's connected to your network, what's connected to the fabric. So we've got a nice tight integration with VMware. So we're learning about all of the workloads in this environment, in my VMware environment. So if we look here, you can see these are all my VMs. It tells me what ESX host they're currently attached to, right? If they get vMotion, that would change. It would tell me what are the leaf ports or leaf switches it's connected to, its IP address, its VLAN. But what you'll also see is we're learning about the tags or labels from vCenter. The environment it's a production workload. The app tier or the tier, it's an app. So we learn these things, which is extremely important because what this allows me to do when I have this context about the workloads is I can build workload groups. So I can come in here and say, let's say prod production app tier. And what I can do is I can come down here. These are my vCenter tags, and I can build my own tags manually inside of PSM as well. But for VMware environments, we learn them dynamically. So we can say we want production workloads, but not just prod workloads. We want workloads that are tagged with app, database, or web. And let's say database as an example. Now, what this will do is this is a dynamic group. So if we have workloads sitting on VMware that might be a database, however, they're sitting in the development environment right now, they're not going to match on this group. They're going to match on a completely different workload group. However, at some point, someone might promote that workload from from development into production. Well, that workload is going to need a completely different set of rules because it's now in the prod workload or prod group. So this will happen dynamically. As those labels change, vCenter is going to let us know that this endpoint's workload tag has changed. We will dynamically update the rules with you not having to come in and change anything. The endpoint and the group it belongs to dynamically changes, and we dynamically program the switches and hardware to adjust to this workload's context and labels changing, which is pretty cool. This is something you get with NSX or Guardicore, Lumio, Tetration as an example. And now you're getting this in a hardware switch form factor. So now we have this new workload group called production app tier. So if we come back to finish answering your question, when we created this rule Vandis, right? We'll call it rule 1, and it's a permit. Instead of having to use, again, a prefix, I can now instead use that group I just created, production app tier, can dock to my test environment as an example, and we'll say on TCP 1433. And now I don't have to worry about IP addresses or prefixes. I worry, what this is now more focused on is the labels and tags that I learned from vCenter, and it will dynamically adjust. So we'll save this for later. And the one other way we can do it, Mike, is IP collections. So maybe when I can use tags, great. There might be instances where I know I have a group of prefixes, but I don't want to have to enter those prefixes over and over in the source and or destination. My other option is I can create a group called an IP collection, and it's called client source, added IP address list, just as an example. So we have that group name, and I can add more prefixes in here. but I'll never have to reference or reuse those IPs or type in an IP address again. I can just use this particular name. So I'll come back and I'll show you what that looks like. We'll come back to our Vandis rule. Let's edit it. And then you can see here, I can use any one of those names that represents a group of prefixes instead of having to manually enter in that each time. What do you think, Mike?
That sounds awesome. So now that we know how to create a rule, so one of the things that a lot of our customers have difficulty with when you start implementing a solution like this is identifying, what traffic flows there are between applications and systems. What tools do you guys provide to help people develop those policies and create them in the first place?
Yeah, it's extremely important to help in a zero knowledge environment discover what are the communication patterns that are happening across your floor tiles and help build a zero trust policy around that. So there's two ways. First is we can take policy from third party. So we have nice partnership with Guardicore where we can feed telemetry to Guardicore, and Guardicore will discover policy and they can push that policy directly to us. And the reason Guardicore partnered with us on this is they have a number of customers where, they've got to about 60% coverage of their workloads with an agent, but the other 40%, they don't have a solution. So they're pushing the policy to us and we're able to address that, the unprotected, as Joanne mentioned in the beginning of our session. But we also have our own tool as well, and it's called the Network Graph. So what we allow you to do is we can basically come in here and we generate firewall logs. So we stream them. We give you two options. Firewall logs can be streamed to your existing collectors, but we can also stream them to the Policy Services Manager. So what we do is on a per Verf basis, we can look at what are the firewall logs or flows that are happening across your data center environment, whether it's past hour, past day. We'll be increasing the capacity of this over looking at past weeks. But for now, let's say for the past day, again, this is a lab environment. We've got 26 flows, not a lot. Like I said, it's a lab environment, but you can see the timestamp when this flow happened, what was the source IP, the destination IP, what is the destination port, and then we can further consolidate it down and understand what are the unique flows that we're consistently seeing inside this Verf. And we can even further filter by looking at specific VLANs as well. The same VLAN or different VLANs talking to each other and understanding what type of conversations are happening. So what we can do from here is I can come in and start to look and say, okay, .2 is talking to 0.2 on port 2048 5 times in the last day. But that seems to be a common flow that's happening. So one way we can do that is we can just take that particular flow that we've seen happen X number of times, and we can just pop up and create a new rule out of that. So we can add it to an existing policy as a new rule, or we can come in and create a brand new policy. We'll call it Vandis 2, give it a rule name. We can even change the order or insert where we want the order to be if it was part of an existing policy, and we can enter in those IP addresses. Now, the other way we can do this, and this will be a future software release, most likely around the early 2024 timeframe. As you can see right now, we're giving you the visibility on what's happening across your data center, but you're still manually building the rules. But we're giving you a hint on what's happening. What will happen in the next iteration of this particular feature set is when you come into this page, we'll dynamically build the rules for you based on the last time domain of conversations that were happening, and we'll recommend policy to you. And then you'll be able to go in and approve whether or not those are the rules you want to happen. Very similar to what your user experience is inside of Tetration, Guardicore, Lumios. We'll dynamically discover the rules, and then you approve them or say, yep, that flow or that conversation should not be happening. We shouldn't see development workloads communicating with a production database, as an example. Don't approve that. And we will allow you to iterate on that process over different time domains. And what I mean by time domains is When you discover policy, you need to look at data over at least a quarter, because I think we all know applications behave very differently the first 89 days of a quarter, and then on the last day of a quarter or last week of a quarter, applications do different things. They might back up differently. I might have to close things out, or certain processes might not run until the end of the quarter. So you want to have that extended time domain to understand how applications communicate. So that's what some of the native functions are inside of PSM, and they will continue to evolve to help you dynamically discover policy. But good question, Mike. What would you like to see next, Mike?
Yeah, so now that we know how we create a rule and how we can build some of those. So depending on the structure of the organization, some organizations want to have different app owners or different groups manage the security policies for their applications. Where and how do we apply these policies, and how can that be done?
Yeah, and this is something I think is very unique to what we've built here, because I spent 20 years at Cisco, and as an example with ACI, it's a very flat policy, right? An endpoint can belong to one group, and then you build your policy around that one group. And like I said, it becomes very rigid because it's not very flexible. Sometimes I need endpoints to belong to multiple different groups, and I need to apply it differently. So what we've done is we've given you the ability to have hierarchical policy. And what that means is I have a list of all the VLANs that I want to redirect so I can statefully inspect. You can see VLAN 500 is part of the default Verf. 1014 is part of a Verf called Remote Data Room, as an example. So if we come over here, I can take that Vandis policy that we created, and I can say, I want that policy. Actually, I have two now deployed, excuse me. We're going to do that one. There we go. So what this allows me to do is it says for VLAN 500, whether or not there's traffic that's going between VLANs, the source is in VLAN 500, it might be going to VLAN 501, I want you to take this Vandis policy and apply it to any workloads inside of VLAN 500. And that includes lateral movement inside of VLAN 500, very granular micro segmentation. So I can give an app owner or a security owner to give them the ability to do a very fine-grained policy just for VLAN 500, just for that application, which is pretty sweet. And what you might notice is you see ingress and egress. And we've taken, as I mentioned earlier in the presentation, this technology is being consumed by cloud providers, and they provide you direction on those rules as well, egress or ingress, and you also might see it in Kubernetes environments. What egress means is I want this stateful policy applied to flows that are being sourced from endpoints in VLAN 500. So think of it as I'm sending a TCP SYN from a workload in VLAN 500. I'm going to statefully inspect that particular flow before it tries to get to its destination. Now, on the other side, ingress essentially means I have a flow coming into VLAN 500 that's destined. I have a TCP SYN coming into this VLAN 500, destined to maybe a database or something in that VLAN. And I can provide a completely different stateful policy on that packet before it gets delivered to the destination or that destination endpoint. So very flexible. So that's one way we can do it. So again, very granular on a per VLAN basis. And then I also have the ability to apply policy at the Verf, global policy. So what that essentially means, if we look here, we have a Verf called TPM Verf 1. If we come in here, we'll come back to NAT and IPsec in a little bit, but same scenario. I have ingress and egress security policy. So if I might want to apply policy at the network level, or I might not know where all my endpoints exist, right? They might exist in multiple VLANs, and I don't want to have to figure out what are the different VLANs they sit in. So what I can do here is I can take a security policy and attach it to the Verf. And what that means is every VLAN that belongs to that Verf must adhere to this security policy. So whether that's microsegmentation inside the same VLAN, inter-VLAN traffic, they all packets micro, macro, or zone-based segmentation must adhere to the policy I assigned to the Verf, which is pretty cool because I don't need to get down into the weeds of doing things at the network level. Now, however, where they become really interesting is when you combine both, where I might give an app owner or a network owner the ability to apply his or her own policy at the VLAN or network level. I might want to do things at the global level where I can say, you know what, production workloads can talk to production workloads. Dev can talk to dev. Anything production can talk to shared services. So what that allows me to do is I give the freedom and flexibility to individuals to build their own policy at a network level. But if someone tries to allow a dev workload to line of defense, that hierarchical policy. So even though someone might permit it at the VLAN level, the security team at the global or VERF level says, oh, I'm sorry, we only allow prod to talk to prod workloads. You might have used a policy that said web can talk to app can talk to database, but your policy wasn't stringent enough and it happened to include development workloads. That policy at the VERF level would prevent that from happening. And that is something extremely unique. You will not get that inside of ACI, almost impossible to build with ACLs in a very flat policy model. You could you can do that in those software-based micro-segmentation platforms like NSX, Tetration. But now you have that in your data center fabric to have that type of flexible policy model. What do you think, Mike?
Sounds great. So here as well, a key element in Zero Trust is not just enforcing policy, but also telemetry capabilities. What kind of telemetry capabilities does the platform provide? You talked about IPfix and a couple other things before, but can you go a little more detail to those?
Yeah, of course. So the first thing that you will see is firewall export policies. So what you'll see here is I want to send firewall logs to PSM because it helps me discover policy. But also I can send firewall logs off to third parties as well. So whatever you use today for archiving or collecting firewall logs, we stream it directly from the switches directly to a third party if need be. So when we look at PSM, so we have a list of or an archive of all of the firewall logs and transactions that are happening within our data center. So if we look, let's see, over the past day in my environment, we can see we get the reporter. What was the switch or the DPU that saw this particular flow? What security policy did it match on? The source destination, just like you would expect in any firewall log. This particular transaction is still going. That's why we haven't, until this connection closes, then you'll see the packet sent and received. And then what you also noticed is whether or not there were other services provided above and beyond the firewall. Was this IPsec protected? Was any NAT services on there? So you've got a firewall log for every transaction that happens within your data center as well. The other piece that we provide is IPfix. So this isn't your dad's IPfix. What I mean by that is we have a flexible parser engine. So yes, we provide per packet IPfix, which is cool. I think Cisco does it. Most of the other vendors out there just do sampled IPfix or SFlow. We provide per packet IPfix, but with this flexible parser engine, remember it's a programmable P4 ASIC, the Pensando AMD DPU. So we don't have to spin an ASIC every time we need to change something. We're able to reprogram the ASIC. So we provide, of course, the standards-based IPfix. But we've had a number of customers say, hey, could you report on packet loss? Can you detect when you're seeing TCP retransmits? So we adjusted the parser engine, and we can now detect on when we're seeing TCP retransmits, which is a great indicator there's packet loss happening somewhere. Is it in the network, or is the database getting completely overwhelmed and it's causing back pressure to the sources that are consuming data or writing data? Another example is we've had some highly security conscious customers that are concerned about data exfiltration, where there's some black hats that are using fields within an IP header to leak data in those used or unused fields. And what we can do with our Parser Engine is look for ASCII data where in these fields where we shouldn't see ASCII data, we should see QoS values, something else. So here's just an example of where you can turn on IPfix and stream that out to existing collectors where you can run different algorithms across that data, whether it's in the NDR or XDR type environments. So what do you think, Mike? Pretty interesting from a telemetry perspective, what we can generate above and beyond just, stateful firewall and so forth. It's pretty rich, the telemetry, and I kind of think whether it's, if it's firewall logs or you need both or one or the other, having that flexibility, I think is pretty unique. The one other thing I forgot to mention, and I wanted to bring this back, was what about when someone opens a ticket and they say, hey, I can't communicate with this particular destination? What typically happens? The network team's always the first culprit, right? Something's wrong with the network. I can't access this database. Well, just like with any firewall management tool, you got to be able to quickly evaluate, doesn't a rule exist that is preventing these two endpoints from communicating? And embedded inside of PSM, we have the ability to quickly evaluate the security policy where I can enter in the source IP, or I can enter in a workload name, the destination, the Verf, the VLAN, and so forth. And what it will do is it will pull up all of the security rules that match on the criteria I entered. So it will tell me within seconds, is my security policy too restrictive? Is it preventing this source and destination from communicating? Or it comes back and says, no, it's absolutely permitted. So we can kind of take the finger from not being pointed at the network team or security team and say the network is not dropping it. Excuse me, the firewall's not dropping it. So we've got a very quick way of doing that as well. And then the last piece on the firewall I wanted to show you is, again, just kind of taking those best of breed firewall management functions is, let's say, for instance, I need some lifecycle management of this policy. So I can also take this policy and clone it. And then I can have another version of this policy where I can edit it, make some changes. And then when I have different versions, version 1, version 2, version 3, I can switch back and forth, as we talked about before, about what policy I might want to have enabled within the fabric. So all of those features and functions around very enterprise class firewall management, you're now getting as a service with your data center fabric as well. What do you think, Mike?
Sounds great. So I know I've been kind of occupying your time here, so I'd like to see if anyone else on the call has any other questions for you. So we'll open it up to questions to the group at this point.
Cool.
And so if anyone has any questions, you can either submit them in the chat, or we're a small enough group today. If you just want to unmute, ask your question, and we'll address it.
Well, as we wait for some questions.
Yeah, if not, I got one more for you. If you don't mind.
Please.
Yeah, so I mean, you kind of talked about it, and I know it's a new feature to the platform, but the NAT and IPsec features. How are those policies configured? I see the tabs on the left, but I haven't really delved into those yet myself.
Yeah. So this is pretty cool. Again, I still wrapping my head around all of this function in a 1RU switch, especially at the cost of a 1RU switch. This always blows my mind. But we can come over. We have NAT policies. So again, give it a name, Vandis NAT, and we'll give it a rule name. I'm not very creative with those. Again, same scenario. I can keep it enabled or disable it for later. But I can come in here and I can build source NAT, destination NAT, or twice NAT, where I need to translate the source and destination, and then also the ability to translate the ports as well, as an example. So I can, again, do it based on IP address, and I can also do it based on IP collection as well. So I can say I want to translate my source client IPs into my NATed client IP source. So, and again, this is something that we would distribute into the fabric. Today, this is implemented on the border gateway functions. So ingressing and egressing of a data center fabric, as well as the ability to do it between VRFs, especially in shared environments where resources might sit in a shared VRF, and I have multiple clients or multiple customers that have their own dedicated VRF, but they need to all access something that's shared, and they might have overlapping IP addresses. So this is a great way where when I'm going from one VRF to another, I can use NAT as a way to make sure that addresses don't overlap when they access something shared. And not just NAT, also providing that firewall function between VRFs as well. And then the other piece to talk about is IPsec. So we've been doing a bunch of interop testing, whether it's with Juniper SRX, Viata, Firewall, Palo Alto, Cisco and Fortinet, where but when you can come in here, you give it a name, call it Vandis IPsec. We have 3 different HA modes. It could just be a single device building a single tunnel. We can do active-active, so we have 2 CX10Ks, each building 2 tunnels out to a remote location that have 2 tunnels, and we can have both tunnels sending traffic ingress, egress, or we can do an old school active standby, active passive HA mode as well. But you can come in here, you would define your tunnel name. So you would define a tunnel within Aruba CX. It's basically a VTI type tunnel. You define your IKE version, V1, V2. You define what are the border leaf switches I want to send this policy to. And then I can go through and set up my IKE security association parameters and my IPsec security association parameters. And that's it. Now I've also got the ability to do IPsec to build tunnels out to third-party VPNs, encrypt express route circuits out to an NVA or a virtual appliance sitting within a cloud provider, or just back-to-back 10Ks where I want to use the 10Ks to encrypt a DCI connection. And then the ability to have up to 400 gig of IPsec in a 1RU appliance. I can think of the number of different fiber connection interconnecting data centers or co-location facilities where we can use IPsec. And why that's important is over the years, customers have been using MACsec to encrypt some of these links. And one of the challenges with MACsec, although performance is great, is the packet is always clear text inside of the switch. It's only the link that's encrypted. So there's a point of vulnerability inside of the switch where I think we all know IPsec is end-to-end. So if there's other hops in the path, the IP packet will be encrypted end-to-end between 10K and whatever that remote VPN device happens to be. So very cool. So to summarize, whether it's stateful firewall policies implemented in a micro, macro, or zone-based segmentation scenario, the ability to provide NAT, IPsec for site-to-site VPNs or DCI encryptions, very rich telemetry, the ability to understand what's connected to the data center fabric, so I don't have to just deal in the world of IP addresses and IP prefixes. I can deal with human readable names and workload groups. It's the platform is pretty impressive with what we've built so far. So if there's any questions, I'm open to answering or showing additional things through UI if anyone's interested. Otherwise, I'll pass it back to Joanne and Mike.
All right. Yeah. No. Does anyone else have questions that they wanted to ask? And if not, I got one last one for you. So
Yes,
we've been looking around in this is all PSM, right? So this is the PSM tool.
Yes.
So you mentioned Fabric Composer. Everything we can do here, we can do in Fabric Composer for customers already using that.
Yeah, that's correct. Let me show it to you. So you can see Fabric Composer, right, Mike?
Yeah.
Just making sure. Okay. Yep. Perfect. So what you'll see here is AFC, and this is tremendous tool. I mean, just as an example, when I first, 2 years ago, when I first got my first bits on AFC, installed it, I refused to grab a manual. I said, let me see how easy this is. And, spending all my time working on ACI when I was at Cisco, and you always needed a manual nearby to figure out how to do something. If you haven't worked with AFC, they have these guided setups with building out an EVPN VXLAN based fabric or just a back-to-back VSX configuration. It has this, without having to have a manual, I can easily go through this guided setup to build out a fabric, which I absolutely love. The other piece, which I think is really, really cool, what they've done here is their really rich visibility in VMware environments. So if you look here on the left-hand side, here's just as an example, Leaf 1, CXT Leaf 1. You can see it shows the LLDP information down to this VMware ESX host. It's .111. And I can see all of the different VM NICs. There's a bunch. Some of them are not connected, but VM NIC 4 and 5 connect up to me. I can see the distributed virtual switch. I can see all of the port groups that have been configured, and I can also see all of the VMs in the environment as well. So troubleshooting wise, I've got visibility all the way down to the virtual machine. I was showing you guys earlier that Apache web server. Now, what's awesome about this is I can also build policy and port groups directly through AFC as well. So if I don't want to go into vCenter, I can build new port groups for VMware directly through AFC, and it will provision VMware's distributed virtual switch as well as this interface to make sure the proper VLANs are trunked. So it takes care of both sides of the connection, which is super awesome. Now, on the PSM side, what you'll notice is it has an integration with the Pensando PSM. So everything that I showed you through PSM, I can all do through Aruba Fabric Composer as well. So if we come over here, I have a list of endpoint groups. So for instance, AFC as well can leverage those tags that we learned from vCenter. So if we look here, we can do it based on VM name. Here's all of the VM names inside of vCenter. I can do it based on tags if I wanted to. Right, there's all the different tags that we talked about. I can even do it based on VM kernel, where I want to build policy for VM kernels as well and use those as endpoint groups. So Aruba Fabric Composer can do that as well, which is awesome. I can come in and I can build all of my different rules. And what's fantastic about this is this all gets pushed through PSM through its RESTful API and then gets distributed to all of the leaf switches that need that particular policy. Very, very cool what the Aruba Fabric Composer team does. So whether or not with roles-based access control, we can give the network team access to configuring all of the network components of the fabric, and then we can lock this down where either the network team or the security team can build your stateful firewall rules, and then NAT and IPsec, as soon as we GA, that will be added to AFC as well. And you'll learn more about this in the 2 new webinars Joanne will talk about at the end of the session today.
Wow, this is pretty incredible. Thank you so much for doing this, Jason. Mike and I really want to thank you for your presentation today and this very detailed demonstration of PSM and even now just the Aruba Fabric Composer. So thank you for that. As Jason mentioned, if you'd like to learn more about the solution and get your hands on it using Aruba Fabric Composer, we have 2 workshop sessions. One will be on May 24th and the other is June 13th. And you can sign up for those by visiting the events page of our website, vandis.com/events. Finally, we would like to also thank you for joining today's demo and staying on. If you have any questions or would like to set up a demo specifically for your team, please reach out to us at info@vandis.com. And again, thank you. Have a wonderful rest of your day. Bye-bye.